There is also another technology I want to mention here, which is OpenID. OpenID is a system where you have one login at one web page, and you can use the same login on other web pages. So with OpenID, you would have a login on the Dreams platform, for example, or on burnertickets.com, or on the wiki. We just have to decide which system is the master. Maybe Burner Tickets, maybe the Dreams platform, and you can then copy paste URI identifying yourself and use this URI to log into other platforms. What happens then is that the platform where you want to log in makes a redirect on the URI and basically bounces back between the two systems. There's a challenge response thingy, and you get a token saying that you're authenticated and identified. And OpenID is, for one thing, it's web-based. It's completely, the web is the platform. It's a few redirects. There is lots of implementations. Probably we have OpenID support out of the box. And you can also attach data to people here. So you can say, Leobard and telephone number, yada yada yada, or other things. And so while I'm promoting resource description framework, I'm also saying we should look into OpenID, because that may be a good solution to the login problem. Now, the same idea somebody else had. And here we come to my last slide. The idea to use resource description framework, OpenID, to connect systems and exchange data and integrate systems was also taken up in the last years from somebody called Pim Berners-Lee, which I already mentioned. And he designed a system called Solid, which combines identification and data storage. Now, I wouldn't go all in on Solid currently, because I haven't programmed it yet. I have never used it before. I'm just mentioning that Tim Berners-Lee, the inventor of the web, is currently working on a system that may be interesting to us. But if it doesn't work yet, if the libraries are not cool, then we don't have to use it. We can just use OpenID, linked data, resource description framework, and we'll also be fine. There is one more point out about the architecture here. There is one more thing I want to say about architecture and putting all these things together. When we make data exportable from the individual platforms using RDF, then we could do the data integration using individual cores or HTTP cores. So if the Dreams platform wants to show the hammer corrector dream, and it needs to show the updates, the related wiki pages, and for example the GPS position, which comes from another system. There's two ways how to do that, and one is to query the other systems and ask, do you have data I need, and what is the data? So the Dreams platform could query the map, for example, and ask, I have an URI here, the hammer corrector, do you have latitude and longitude of that? And here we have an interesting thing, namely when you talk to the map will probably just have a list of all of the entities. I'm now making a small shortcut. The map may know that the hammer corrector dream has geo positions, lat and longitude like that, but the map will store this in a database with many of these facts together. So you would probably have 20, 50, 100, 200 objects placed on a map, or resources placed on the map. And now to query the data, what is the GPS position of the hammer corrector? It gets a bit tricky because you would have to iterate through that. Now, what you could do to make this more efficient, you could query the whole map, the whole database, and while you're at it, you could also query the whole wiki, all the data that's in the wiki, everything that is in the what, where, when guide, everything that is on the comms, whatever you want, and put it into a graph database. But only for indexing. For data exchange. So when you want to show related data on a Dreams page or on a wiki page or wherever, it's good to have a central graph database where everything in our whole community, in our ecosystem is indexed. So we could make a graph database and say once a day or when there are changes, we crawl everything, have it in one graph database and can ask queries. And in RDF, there would be, for example, Joseki. Or the, yeah, hang on. Which is from the Apache Jenna project. And Joseki is an RDF server, which is written in Java. You run it in Tomcat, and then it's there, and you can dump RDF into it and get RDF out of it. It's very simple, it's very small, and relatively easy to set up. And it has an interface for querying called Sparkle. And with Sparkle, which is a query language, you could basically ask queries in the format as an example here. I want to query for the pattern the hammer character as a subject and any predicate and any object you know about it. So this query would basically resolve in the database, looking up all the facts about the hammer character and just putting them out. And that would allow us to later plug in more systems with adding more data also. And basically what you can then do is on the hammer character page, to get the map coordinates, you would shoot a Sparkle query to this sample index here, saying, give me the, you can restrict this here, give me the GPS latitude and longitude, and then just render here the latitude and longitude. The same you could query for stuff on the wiki. You could say, give me all wiki pages that are related to the hammer character, run the query and display the names of these wiki pages. So when we come to a graph database, I wouldn't use it as primary storage for building applications. I've tried that in my past. It usually takes much longer and is less convenient than using a good framework such as Django or Ruby on Rails and a relational database mapper, because they work much better to create applications. But when it comes to data integration and showing data at one point which comes from another system, then a graph database such as Joseki, Apache Gemma, for indexing is great, because all you have to do is take the RDF data that you get from the different websites, dump it into the database, and query it. It's very, very easy to do, and it gets the job done to, for example, show GPS positions here. And you, as you know, from graph databases, you don't have to create any schema in the database, no problem. And again, we don't have to discuss about how to represent geolocations, GPS. No, this has all been done. So we would just go to the linked data chat and say, hey, we have this problem, tell us what. Then Timber will probably say, use solid, but we'll see. And in the resource description framework, I know that Dan Brickley, hi Dan, I'm talking about Semantic Web, I'm talking about you, that Dan Brickley is still running schema.org and hundreds, if not thousands of people are contributing to this project. So it's extended every day and it's used by many websites. So if you want to dive into this, then I would really say we could reuse all these vocabularies and the data formats from schema.org and reuse them to exchange data between the websites. This is a proposal which I think would be a nice way to get all these pages together. I think on the long run it's the better way to use the linked data platform and the linked data principles and the resource description framework principles as a platform, because they are built for exactly what we want to achieve here, to integrate different systems. It's up to you to decide if you go for something like that, which is a neutral platform, or if you go to implement individual APIs. You can always say, no, we're not going to use all this. We're just gonna integrate one system with the other. But the experience tells us when you start integrating the fourth or fifth system with all of the others, work gets more and more. So that's it. I don't have more. No, so yeah, so you can always, one possibility is to use RDF. The other possibility is you can always integrate individual systems. You can say I integrate Dreams with the map, I integrate Dreams with the comms platform, I integrate Dreams with Participio, and or realities, so with different interfaces. At one point, I guess all the integration will get hard and will get a lot of work. And by reusing the resource description framework, which was invented to create a free web of individual web services that can talk to each other, would be the more elegant solution. And we would make friends with lovely people. So the people who are developing resource description framework are people who are standing for a free world, through a patent-free world, through a world that is based on standards. The people who are involved in RDF typically want to integrate systems, want to integrate various people together, people, systems, organizations, etc. It's the opposite of the walled gardens that we are seeing currently in Facebook and in other centralized services. Mainly Facebook, which is pulling in all the social media. So I would think that by asking the RDF community and collaborating with them, we would also get in touch with some interesting open-minded persons who may share a lot of the ethos and mindset we have in the Burning Man community. So I personally I'm a burner. I'm all for collaborative creation and co-creating. And I've seen a different spirit. I've seen the same spirit and the same mindset of people collaborating in the resource description framework community, in the RDF community, where people want to empower individual developers to create their own web service, to create their own thing, but to connect to each other and respectfully use the data from other people. So I also promote this idea of RDF because I think we're a good match from the mindset. That's it. Greetings from Vienna. Bye.